So we're going to start a new lesson on trig graphs. And we've talked about the unit circle and the trig ratios. So the unit circle kind of pulls everything together, and when we graph our trig functions and look at it on the xy plane, then it really helps to bring together even more the ideas that we've been talking about so far. So let's think about what it means if we were going to graph y equals the sine of x. And we're going to use x this time because we want this to be on the xy axis. We don't want to look at it like a ratio of sides on a triangle. So for this one, instead of using theta, we're going to use x. So if we were going to graph this, and let's relate it back to our unit circle. So here's my circle, and this is the origin, so this is 0, 0. And let's think about what happens if we start here and we rotate counterclockwise. So we're going to start at 0 degrees and work our way back around to 360 degrees. Now remember, the x value is the angle. So for the sine function, the x value is the angle. So if we start at angle 0, the y value, the sine value for that same point is going to be 0, 0. Because remember, the ordered pair for this point is 1, 0. So the sine value for that point is 0. So this graph starts at the origin. Now let's just use our our benchmark points here on our x and y axis, those x and y intercepts, to find out what the pattern of the graph looks like from here on. So we know that the ordered pair here is 0, 1. The ordered pair here, -1, 0, and then ordered pair here, 0, -1. Now, the sine values for those points are always the y value. So it works out really well that that's the y value in this case too. So this is at 90 degrees. And we can do this in degrees or we can do it in radians. But we're going to start out. So this is 0. This is 90 degrees, or pi over 2. This is 180 degrees, or pi. This is 270 degrees, or 3 pi over 2. And this will be 360 degrees, or 2 pi. So let's just look at where those points are going to be as we move on. So at 90 degrees, the sine value is 1. So at 90 degrees, the sine value is 1. It's going to go up here. At 180, it's back at 0. At 270, it's at -1. And then at 360, it's back at 0. Now we can keep making as many rotations around this circle as we want to. It goes on forever in both directions. So let's look at what this looks like. This is called a sine wave. And that's one period of the graph. So I can take this section and replicate it as many times as I need to the right and to the left. So this is going to go on forever, that same pattern in both directions. So it's just going to keep doing that wave thing forever and ever. So this is called, let's switch colors. This is called the amplitude, the height of the wave, so how far up it goes. So the amplitude is 1 because from 0 to 1 that's a distance of 1. So I'm going to keep a record of this information about our sine wave at the bottom, amplitude. And the period, it repeats every 2 pi. So remember, from 0 to 2 pi was one section of that graph. So if I take that one section and repeat it over and over again, that's how I form that whole graph. So the period, one piece, is 2 pi, or 360 degrees, but most of the time we talk about it in terms of radians instead of in terms of degrees. So we know that 2 pi and 360 are the same thing. Now, we're not always going to have just this regular old graph. Sometimes, remember, we've got in algebra, you can start with y equals x. But then we can start stretching that graph and shifting that graph. So we might have y equals 2x minus 1. So it's steeper and shifted down 1 unit. We can do the same thing to these types of graphs, so we need to know what it means when we shift and stretch those graphs in different directions. So this is going to be, this is the general form, y equals a sine of k times x minus b. Now this whole thing is what we're taking the sine of. So this, you can think of it as being in brackets if you need to, so that you know that whole thing is what we're, the sine of this whole piece. And the a is a coefficient, so it's the out front part. Now in part 1 of pre-calculus, we talked about function families and how to shift and stretch and change those. We talked about reflections and all of those different transformations that we could do with the graph. We can do the same thing with trig functions, and it works basically the same way. So let's talk about what each one of these pieces means. So the absolute value of A is going to be the amplitude. Remember, that just means the height. 2 pi over the absolute value of K is going to be the period. And B, we call it the phase shift, but it means the same thing as a horizontal shift. So remember, the phase is how wide this is, so this is called the phase shift or the horizontal shift, so how much we shift it from side to side. So let's look at an example of this, and just in case you need it for reference, I'm going to put the ordered pairs that go with this graph right here. So these are the ordered pairs that we got from this graph. So just in case you need that, this is our x value, our angle, and this is the sine of that angle. So remember, we had 0, 0, 90 degrees or pi over 2 was 1, 180 degrees or pi was 0, 270 or 3 pi over 2, that was negative 1, and when we made it back to 2 pi, we were back to where we started at 0. Now, I know we came back to 0 in the middle, but notice how if you just take from this 0 point to this 0 point, it's just the top of the hill, it's not the valley part. So we have to have that whole piece for it to be one period, so that I can repeat that whole curve over and over again. Okay, so let's do an example, and this is kind of what our problems will look like on this section. What if we were supposed to graph y is equal to 2 times the sine of 1/2 theta. Now that we know that we're graphing this on an XY plane, if we use some other variable to represent the angle, we already know that it's going to be on the XY axis. So that theta is taking the place of an X. Okay. So let's move this back down so we can look at it. Let's use this information to figure out what this graph is going to look like. Now, of course, you can type this into a calculator or into Desmos or whatever you want to use to find a picture of this, and it'll give you that curve. But we need to know this specific information, the amplitude, the period, what the phase shift is, and we want to be able to sketch it by hand, because on your calculator, the x-axis is just labeled in numbers, but whenever we actually graph this, we want the x-axis to be labeled as angles. Okay, so it's going to change the way our graph looks just a little bit. Not the shape of it, but just the information that we already know. So this is the A value, and this is the K value. There's no B in this one, so there's nothing added or subtracted onto that theta. So we just have an A and a K. So the amplitude for this one, remember absolute value just means the positive value. So amplitude is going to be 2. And then the period this time, this 1/2 is going to change how wide that graph is. So sometimes we have that squiggle happening in a very short space and it repeats really quickly, and sometimes it's more spread out. So our curve is really spread out like across the page. We need to see how wide the period is going to be for this one. So period is 2 pi over the absolute value of K. So in this case, that's going to be 1/2. And if we simplify that, that simplifies to 4 pi. So this one's going to be twice as wide as that other one is. And there's no B value, so there's no shift. Now notice how the curve up here is split. We talked about this as our quadrantal angles. So where our angles on the quadrants were, so it was split into fourths. Notice that my graph here is split into 1, 2, 3, 4 pieces for each period. I want to split this period into 4 pieces also. So we need to split this into fourths. So something special is going to happen. If we divide this into fourths, something special is going to happen on each pi value. So if we want to graph this, the labeling is very important. So we've got 0, and remember, pi is going to be where important things happen in this case. So this is going to be 1 pi, 2 pi, 3 pi, and 4 pi. And since it's a sine function, it's going to have the same general shape. So we're going to start at 0, and then we're going to move up to 1. Oh, sorry, 2, because my amplitude is 2 this time. So it's going to move up to 2. So 0 to 2, back to 0, down to -2, and back to 0. So this is what one period of my graph is going to look like this time. Now, I don't have it set up on the same scale, so notice that it kind of looks the same as that one, but this one's a little bit taller. If I set it up the same, then this one would look more spread out than the other one, because this one goes to 4 pi, and for this one up here, the period only went to 2 pi. So just keep that in mind. It's kind of like when you change the window on your calculator, and something, a line or shape might look the same, but you're looking at it on 2 different scales. So be careful with the scale of these problems. Okay, let's do another one. Now on this one, we're going to add in a shift. So if I want to add in a shift, then this one's going to have a B value on it. And that last one did not. So example number 2 is y is equal to sine of 2 times x plus pi over 2. That'll be our next example. So let's label the pieces. So remember, we've got the a out front. So for this one, my a value is 1, because if there's nothing out front, then that coefficient is always 1. This is the k value. And then this is our b value, and we call that our phase shift. So sometimes we simply abbreviate that PS for phase shift. So let's record that information. The amplitude is 1, because it's the absolute value of the A. The period is 2 pi over the absolute value of K, so the absolute value of 2 is just 2. So that simplifies to pi. So remember, when we split our graph up into sections, we want to split that up into fourths. So if we divide pi into fourths, then every pi over 4 sections, every fourth of a pi section, something's going to happen. So that's how I need to split up my points on my x-axis for this one. And then we've got to add in our phase shift. And just like we talked about in the last part, if we add pi over 2 on the inside and it's a horizontal shift, it's going to be in the opposite direction that we expect. So we're going to shift this pi over 2 units to the left. So it's a plus pi over 2. We're going to shift it to the left. So let's draw an example. When I make graphs that have been shifted, I usually like to draw them without the shift first and then draw them with the shift, because I think that makes it a little bit easier. Then you're only doing one change at a time. So the amplitude here is going to be 1. And remember, I need to split my graph into fourths of a pi. So this one would be pi over 4. This one would be 2 pi over 4, which is pi over 2. 1 pi over 4, 2 pi over 4, 3 pi over 4, and then a whole pi. And we could keep going if we add another fourth. 1, 2, 3, 4, 5 pi over 4, and then 6 pi over 4 would be 3 pi over 2. And we could continue on so that we could get an idea of what it looked like. Now, when we have a shift, especially one that's going to the left, we want to label a couple points on the left side so that we know where we're going to shift to. So this would be negative pi over 4. We're just going to mirror these points on this side. I'm not going to put as many because we're not going to need them. But there we go. Now, since we're dealing with a sine function, this one's going to be without the shift. So I start at 0, and then I come up to 1, back to 0, down to negative 1, back to 0. This is my graph without the shift. 1 period, no shift. Now let's adjust and show that shift. So this says that we've done a phase shift pi over 2 to the left. So I need to move this point, each individual point, I'm going to move pi over 2 to the left. So this move to the left pi over 2 is going to put it here. This to the left pi over 2 will be here. So it's 2/4, right? We're moving 2/4 over each time. 2/4 over and 2/4 over. So those teal points are going to be the points of my actual graph. So this is what it looks like with the shift. And we could continue on up, middle, down, middle. There's another phase. Kind of missed that point right there, but that's what it would look like on this side. And then we would go continue in the other direction, down, middle, and we could continue on. But remember, the part that we're really interested in, that one phase, is that piece right there. So that's with the shift inside that box in the teal. So it kind of gets a little bit messy if you've got pencils or if you have different colored pens that you can use whenever you show that shift that's been moved over. Sometimes that's helpful. Now let's talk through the sine function, or the cosine function. That was the graph of the sine. Let's do graphs of cosine next. So if we're going to graph a cosine wave, let's do this again. We're going to start with just y equals the cosine of x. So remember that x is the angle. We're still going to use those quadrantal angles. So we're still going to go back to just that 90, 180. That's not quite a circle, but we'll pretend it is. And 360, 270. So we still are really interested in the points that are on the x and y axis. So this point, remember, at 0 is 1, 0. This point at pi over 2 is 0, 1. Pi is at point -1, 0. And 3 pi over 2 is at 0, -1. So remember, last time we were talking about the sine value. So remember, our ordered pairs for these points are cosine, sine. So this time, we're looking at that first part of that coordinate pair for each point so that I can know what I'm supposed to graph. So let's make those ordered pairs. This is my angle, and this is the cosine of the angle from my unit circle. So we're going to do 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if we look at these ordered pairs and we pull those cosine values out, we're going to start at 1, 0, -1, 0, and back to 1. So 1, 0. So this is going to have the same general shape, but it's going to start in a different place. So looking at that sine wave, or that cosine wave in this case, we're going to start at 0, and then, pi over 2, got ahead of myself, pi, 3 pi over 2, and 2 pi. So at 0, we're at 1. Notice this time, instead of starting at the origin, we've started up at 1. And then at pi over 2 is at 0. And then at pi, we move down to -1. 3 pi over 2 is at 0. And then 2 pi is back up at 1. So in this case, notice it's the same general shape. So I could continue on in both directions. And it's going to be just like that wavy sine function that we just talked about, but it starts and ends in a different place. The amplitude is still 1, so the height here is still 1. The period is still 2 pi. We get one whole section of the graph every 2 pi sections. So there's not a lot of difference. We find the period, the phase shift, and the amplitude the exact same way. So let's write out our general form. Y equals A cosine of k times x minus b. And again, that k times x minus b, that whole thing comes with that cosine function. So that's all hooked together. Again, absolute value of A is the amplitude. 2 pi over the absolute value of k is the period. And B is the phase shift, or the horizontal shift. So let's try one of these. What if we have y is equal to -3 cosine of 2x? Now in this case, remember the sine function always started at the origin. It didn't matter if it was stretched up or down. In this case, it's always going to start at the a value. So if it's negative, think about like a quadratic. If you have y equals x squared and it's that U shape, but if you change the coefficient out front and make it a negative, y equals -x squared, it flips it upside down and makes it a heel shape. That's the same case here. If there's a negative out front, it's going to flip it. So instead of starting at positive whatever the a value is, it's going to start at negative whatever the a value is. So it changes just a little bit. So it's going to start at -3, and I'm going to go ahead and put that on my graph. So that's going to be my starting point. The amplitude, the height of this from the origin to wherever the peak is, or from the x-axis to wherever the peak is still the absolute value of A. So the amplitude, the height here is just 3. So that's why we take the absolute value. We just want to find that distance. And when we're talking about a distance, it has to be positive. For this one, the period, remember, it's 2 pi over the absolute value of k, just like on the sine function. So absolute value of 2 is 2. That means this is going to be pi. It's going to be just like that last one that we looked at. So if we divide this into fourths, that's how we're going to label this axis. So this is going to be at 0, and then pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. And then pi. So that takes care of the whole period, but I've split it up into fourths so that I know where to put those points that we were talking about. So in this case, it's going to be -3, 0, +3, 0, -3 on the scale that we have labeled here. And there's no shift for this one. There's no b value. So we don't have to worry about a shift. So we're at -3, 0, +3, 0, and then back down to -3. So the shape of this one looks more like this. It's steeper and more scrunched up. But this is still, this section, that's one period. So that's the only part that you have to draw. We could take that piece and repeat it over and over again wherever we needed to, and that would give us that whole graph. So let's do one more of these. And we'll talk a little bit about a vertical shift. We already know what these look like from our regular lines and curves that we talked about in part 1 of pre-calculus, but we can apply it to trig functions also. So example number 2, y is equal to -1 plus the cosine of x minus pi over 2. So this one's a little bit tricky. You might want to get your calculator out just to help you because there is a phase shift and a vertical shift. But again, I would graph this without the shifts first so that I could see what the original looks like, and then I could shift it left and down or right and down, whichever the case happens to be. So in this one, this is called a vertical shift. And it's going to go down 1. So just like the graphs that we dealt with before, if it's a vertical shift, it's going to be a plus or a minus, just a number that's tacked on to the end and isn't part of the actual function. So this tells us how we're going to move vertically. The a in this case is 1 because that's the coefficient here. The k is also 1 because that's the coefficient of what's inside these parentheses. And then this is the phase shift. And remember, it's the opposite direction that you expect. So this is going to go to the right. Since it's minus pi over 2, we're going to go to the right pi over 2. So just to summarize this a little bit, the amplitude is going to say 1, because that's the a value. The period is 2 pi over k, but k is just 1, so the period's 2 pi. So if we divide that into fourths, then I want to split my y-axis up into pi over 2 pieces, because this would be 2 pi over 4. 2 over 4 simplifies to 1/2, so pi over 2 is how I want to split that up. And just to reiterate, we have a phase shift and a vertical shift. We're going to be moving pi over 2 to the right and 1 down. So let's sketch this out and see what it actually looks like. Now I'm dealing with a cosine graph, so remember a cosine graph always starts at the a value. So for this one, it's going to start at 1. And then we need to split this up into pi over 2 pieces. Those will be pi over 2, pi, 3 pi over 2, and 2 pi, just like our original. And we're going to follow that same pattern. So 1, 0, -1, 0, +1. That's the original graph. No shift. That would be that parent function that we talked about. It's not shifted. But we're supposed to move each of these points pi over 2 to the right. So this point's going to move pi over 2 to the right. And then also down 1. So this point has moved right and down, and it's going to end up on top of that point. If we move this one right and down, it'll be here. We need to move this one right and down, which will put it down here. This one right and down. And then we'll have to add another point in. This one will be right and down. So our shifted graph will be here in pink. And that's the one we were going for, is that pink version, not the purple version. So that's with the shifts included. So it actually goes down to -2, and on over here to 5 pi over 2. If we wanted to label all of those points. So keep these in mind. I'm going to post a couple problems for you to try, and if you have questions, email me and let me know.